we'll try to do another theorem now. This theorem is 9.5. Okay, we just finished 9.4. 9.4 and 3 were opposite to each other, you remember. Now 9.5 will tell you a new thing about the circle and inside the angles. Okay, so it is interesting. So one theorem is connected to another like this way. So this is how you learn the circle chapter. Okay, what it says is angles in the same segment. Very important. When you are solving your numericals, these are going to be important thing so that you can directly use the results. Are equal. Okay, angles in the same segment of a circles are equal. Remember, there is plural here, angles. That means we are talking about more than one angle. There are 2 angles, 3 angles, 4 angles maybe. So those are all going to be equal if they are inside the same segment. What is segment? What is circle? You have to know, then you will know everything. Circle, chord, this is circle. Okay, this is called circle. This line is called chord, circle, chord, and this space is called segment. If more space is this side will be called this side, all this. Okay, just like the carpet, the floor carpet. Okay, this will be called, the area is called major segment. Why major? Because this is more. The less one is called minor segment. Okay, clear? So in this case, angles in the same segment of a circle are equal. Same segment means either in the minor or in the major, right? Suppose you have a circle, you have a segment, this segment or this segment, whichever may be. In the same segment means, suppose this is the segment 1, this is segment 2. In the same segment, if I have one angle, this one angle, suppose this is 30 degree, I make another angle in the same segment, segment 1, upside, this will also be 30 degree. If I make another angle, this will also be 30 degree. So this is the meaning. Okay, so in the same segment, all the angles will be your same, equal. Okay, this is the one. This is what we are going to prove it. Okay, similarly in the segment 2 also, this will suppose 50 degree or 60 degree or 70 degree, whatever, that will be equal to this angle, 70 degree. Why? Because these two are in the same segment. Here, so this is what is the challenge. We have to prove it, and after that, every time you are going to use it. Okay, let me start. There can be 3 different cases, very simple, not difficult. So we'll write first, given it has to be, have one circle, a circle with center O, angle ACB. Why ACB? You remember now, usually C is kept on the top or bottom there to make that angle in the segment. Okay, ACB, and another one, angle ADB, are 2 angles which may not be equal, may be equal, we don't know, because we are not finished now. Okay, so that at the end we'll prove this, these 2 are equal. Okay, ACB and ADB are 2 angles subtended by AB, this is arc, that means AB, in the same segment. If it is upside, upside. If it is downside, both will be downside. That means same segment. Okay. To prove angle ACB will be equal to angle ADB. Let us make the circle and some more things connected to them. Okay. This will be the circle. There will be three types of circles here. Just put it small. I'll make it a little big here. This is the first one. This will be the second one. One more, let me make it here. This is the first one, okay? The first one is that, suppose this is AB here, circle with center O, and this is your ACB, and this is your ADB. Same segment means upper segment. This segment we are not using. Same segment, two angles are there. ACB, ADB. Now we'll prove these two are equal. Okay, this is case 1. Why I call this case 1 is because in this case the segment is here. In the second case, I'll keep the segment at the center. The line which is dividing the two portions here into two segments. If this is also happening, then also it is true. That means ACB, ADB. Okay, these two angles are equal even when this is passing through the center. This AB is passing through the center. Okay, in the third case, if this happens that the center is here and the segment is here above this center, even then also ACB and ADB will be equal. This we have to prove. This is case 2. This is case 3. Okay, we will not take effort to make many different things. Together also it can be done. Right. So next will be our construction for all of them. Construction says that join OA. Okay, we join OA. Okay, and OB in all the three diagrams. Okay, OB. Okay, I joined it. Here I need not join because it is already joined. Just think that it is joined afterward also. Okay, and here I will join OA and OB. Done. Construction part is finished. Now proof will start, which will give you the answer. What we will do is, we know that the angle subtended by an arc at the center is double. Again, the 9.22 theorem is very important. We know that whenever there is angle subtended and this at the center, this angle AOB, okay, AOB, this angle is going to be half of this, double of this and double of this, AOB. So that we will use it. There also will use, there also will use. Proof, you rewrite the theorem number 9.2 again. That is very, very important. I have already told you. Since the angle subtended by an arc at the center is, more and more time you will write this, you will learn by heart also, this theorem 9.2. Double the angle SUBTENDED subtended by it, means that arc, at any point on the remaining part of the circle. Fine. So what if it is that in this case, okay, I'll write it case 1. What I can write is AOB, angle AOB has to be equal to 2 times angle ACB. Its double will be this AOB. AOB is this angle, will be double of this ACB written. Similarly, the same thing also will tell me that if I choose this angle with this one, angle AOB will be equal to 2 times angle ADB. Why so? Because we know angle subtended by the arc at the center is double of this. At the center is double of this. So both the things are here. Okay. Right. Now what I can say is that if the same angle is double of this, then what I can write is that angle ACB must be equal to angle ADB. Otherwise, same angle they cannot be equal. Its double is also this. Just like double of 2 is 4, double of something is also 4. That means that something is also 4. 2. Okay, it is like that. ACB and ADB are same. That is why their double are coming same. So this is how we are easily proving it. This is case 1. Okay. So now I'll rub this part of the diagram. I'll go to case 2. See, only 3 lines. Just this was important. Case 2. In case 2, what happened? Angle ACB is equal to 90 degree. We already know because it is in the semicircle from theorem, and angle ADB is equal to 90 degree. So they are equal. So angle ACB equal to angle ADB. What is the reason? Angle, that is theorem number 9.3. The angle in a semicircle. Angle in a semicircle is a right angle. So they are both coming 90 and 90, and they are equal. See, in the case 2, easily proved when it is semicircle. Okay. Now the third case. Case number 3 is there. Case number 3, here AB is there, but this AB is the major arc, the bigger one. Okay, if that happens, what will happen is here reflex angle AOB will be equal to 2 times angle ACB. Very important here, very small but important part. The reflex means whenever I write AOB, angle AOB, we will always think about, if suppose this is one angle, I will also always, AOB means I will always think about this angle. Okay, but if it is a reflex angle, then you have to mention here reflex. Then that will mean that I'm not talking about this angle, I'm talking about the bigger one. Okay, so this is same here. This angle I'm talking about, AOB, angle subtended at the center, subtended by the arc. This is the arc, making it at the center, this is the angle. Why this is big? That is why I am writing reflex. Okay, and the rule again same. It will be double the angle subtended by it at any point. Any point are these two. Similarly, reflex angle AOB will be equal to 2 times angle EDP. Same thing. This angle is going to be double of this. So, angle ACB is equal to ADB. We're not going to write this, okay? This is just for example. The three diagrams are of course just before the construction you are already written down. Okay, this way we have proved that it is in the three different cases, angles in same segment, they are equal. Okay, thank you.